Hello, everyone. I want to welcome you to today's lesson. Emeka Udenze is on the line once again, and today we're going to be talking about mass percent. What exactly this means is that we're going to be knowing how to calculate the percentage of each element that make up a compound. So this lesson will be short and straightforward. Let's take it off from there. So our learning goals today, our main objective will be to calculate the percentage composition of the constituent element in a compound, of course, using their molar mass or their molecular weight or the formula weight, depending if the compound is an ionic compound or a molecular compound. So mass percent, again, in the early part of this class, when we did the review about percentage calculation, we talked about that there's need for some knowledge or competence to know how to do percentage. So let's consider a compound, a hypothetical compound here, XY, that is made up of two elements, element X and element Y. Now, if I want to know what is the percentage of element X, what is the mass percent or percentage of X in the totality of this compound, what I'm going to do simply is this, is that, of course, each element has its own, of course, molar mass, right? Each element has its own molar mass or molecular weight, right? Each element has its own molar mass. What are we going to do? What I'm going to do is to add up the masses of each of these elements. Add it up together. Add the mass of this and the mass of this. So the mass of each of this element and the mass of this one will be the total mass, the total outcome. Remember, percentage is usually a fraction, right? It's usually you take an individual over the overall outcome, overall total, times 100 over 1. So what we're going to do is to calculate the mass percent of X, is that I'm going to take the mass of X in the 1 mole. Remember, 1 mole means this is one of these alone. In 1 mole of XY. That is the molar mass of this compound. That is the molar mass in grams. So we take the mass of only X and divide it by the total mass of 1 mole of the compound. Of course, the 1 mole of this compound contains the XY. This is a fraction, and we'll times that by 100 and report our answer in percentages. So this is very simple and short. This is what we're going to do in this class. Let's take a few examples to reinforce that knowledge. It says, the first question says, what is the mass percent? Or you can say, what is the percentage by mass? It doesn't matter how it is phrased. What is the mass percent of sulfur and oxygen in SO3? SO3 is sulfur trioxide. Of course, you have to use your periodic table to figure out what is the individual masses of both sulfur and oxygen. But I just listed them here. Sulfur weighs 32.06 and oxygen weighs 16.00. So the first thing I'm going to do, the first scale here will be to calculate now that I know the individual masses of each of the elements that make up SO3, is to calculate the total mass or the molar mass of SO3. So let me do that. So first of all, I'm going to say SO3 is made up of course, each sulfur weighs 32.06 grams of sulfur plus how much oxygen you have here. There are 3 atoms of oxygen. So I'm going to do, each one weighs 16.00. So I'm going to say 3 times 16, that's 16, let me write it well, 16.00 grams of oxygen. Let me put bracket. So what I'm going to do, to total it now, of course, this is still 32.06, is only 1 grams of sulfur. And here, when you do 3 times 16, it's going to give us 48.00 grams of oxygen. So in this molecule, there is 32.06 grams of sulfur and there is 48.00 grams of oxygen. So now to calculate, I think I'm going to wipe this out. I'm going to remove this for now. Now to calculate the masses, A. So I'm going to start with the percentage of sulfur in SO3 will be the mass of this guy, which is 32.06 grams over the total mass. What is the total mass? Oh, I did not add the total mass yet. You see? The total mass of this, when I add these two together, I have to put it up out. The total mass, which I didn't do, so this plus this, the total mass is going to give me, okay, let me put it over there. See, I didn't add that mass. So I almost missed that. I have to write it out even when I do it. So O So if you add it together, it's going to give you 80.06. Let me write it out well. 80.06 grams of SO3. So when you add both of them together, both of them will give you 80.06. So this is the total mass of SO3. So now, the mass of sulfur on top over total mass, which is 80.06 grams times 100 over 1. And when you do your math right, you're going to get 40.04. I'm going to put it in 2 decimal places, percent of sulfur. You do the same thing for oxygen. In the second part, in the second part, I'm going to do the same thing for oxygen. So for oxygen, which is B, percentage of oxygen will be, again, the total percentage of oxygen here will be, we're going to use a different color, 48 grams. So we're going to say 48.00 grams of oxygen over the total mass of this compound, which is 80.06 times 100. And when you do your math right, you're going to get about 59.96% of oxygen. Now, since that, when you add 40.04 plus 59.9, it's going to give you 100%. So another way you can do this is that if you get this one first, you can also get this one by simply saying 100 minus 40.04%. This will give you, again, 59.96% of oxygen, right? So 100 means the total. You subtract it from the one you have already, you get the one that is left. So this value and this value is the same. If you do it that way, you will also get the same in any percentage problems. Let's go to the second problem immediately. Now, in the second problem here, in reflection 2, it says, what is the percentage by mass of oxygen? Only oxygen is what we're looking for. Oxygen in calcium phosphate. Now, if you look at that, why I put this question is that, again, I try to make you practice on how to calculate molar masses of compounds that have the cations, and particularly where the brackets are involved. So that's what we're going to do here. So we're only interested in knowing the only oxygen part in this molecule. That's our interest here, in knowing the only oxygen part, the percentage. But we have to still calculate the total molar mass. Calcium here weighs this guy. I gave it to you. Phosphorus weighs this, and oxygen weighs this for just one element, one atom of it. If we put all those together, we're going to start. For calcium carbonate, there is 3 calcium here, so it will be 3 times. Calcium weighs what? 40.08 plus the next thing there is phosphorus. Phosphorus is only how many? Look at this bracket, affect everything inside. So there are 2 atoms of phosphorus there. So it's going to be 2 times 30.97 plus how many oxygen do we have now? Again, this bracket, these 2 affect everything inside the bracket. So oxygen was 4. If you multiply it times 2, it's going to give you 8 oxygen atoms. So this will be 8 times 16.00. And if you add everything correctly, this will actually give you 310. So let's write it out. So if you multiply this, it will give you about 120.24 grams of calcium. This is the calcium part. If you multiply this will give you about 61.94 grams of phosphorus. And if you do 8 times 16, this is going to give you about 128.00 grams of oxygen. And if you do add everything together, to give you 310.18 grams of calcium carbonate. So the oxygen part in this molecule is only 128 grams. So what are we going to do? The percentage of oxygen in this guy will give us 128 of the oxygen. We'll put it on top, divided by the total, 310.18 grams, and then multiply by 100. And when you do that, you're going to get about 41.3% into 1 decimal place. That is how you do that second problem. Of course, we'll go to the next one. This one now is an applied question that looks like a word problem, but it's very much applicable, particularly in the areas that we live here that rely a lot on agriculture. Let's see how the question goes. In reflection 3. In reflection 3, it says ammonia, and ammonium nitrate are commonly used agricultural fertilizers in agro-industry. So which one of these 2 contains higher percentage by mass of nitrogen. It's a quantitatively justify and explain. I purposely snuck in those big words. What it simply means is that we should calculate the percentage of hydrogen in each of these two compounds and then compare them. Which one has higher percentage of what? Of nitrogen. Now, if you look at these two, it looks like, this one has 4 atoms of hydrogen and this one has 3. That there may be more hydrogen here, but we don't know. But in this case, you're not looking at the number of atoms, you're looking at the overall mass. How many hydrogen do you have with respect to the overall mass of all other elements that make it up? So let's do that. The first step would be here to calculate the molar masses of each of them. Let's do it. So here for ammonia, we're going to start. Nitrogen weighs what? 14 points, and there's 14.01. Plus hydrogen weighs this, but there are 3 of them, 3 times 1.01. If you do add everything together here, you're going to get about 17.04 grams per 1 mole of ammonia. Now you go to ammonium nitrate. Ammonium nitrate. You start. Nitrogen, there are 2 atoms of nitrogen here, this and this, so you're going to start with 2 times 14.01 plus. Then the next thing you have there is hydrogen. There are 4 hydrogen atoms, 4 times 1.01 plus, and then there's 3 oxygen atoms to be 3 times 16.00. And then when you add all this together, you're going to actually get 80.06 grams of ammonium nitrate. So what are we going to do now is that I'm going to calculate the percentage of hydrogen in this one and percentage. So in this one, the only contribution of hydrogen here is 3 times this. This is only hydrogen contribution here, which is about 3.03 in this one. Oh, we're looking for the percentage, sorry, we're not looking for, I've been talking about hydrogen here. The question is, which of these contain higher percentage by mass of nitrogen? So we're looking for nitrogen. So I'm going to take back what I said earlier. I'm going to take those back, okay? I'm going to take the nitrogen thing I said here back. I'm going to take this one back. Sorry, the hydrogen thing. So we're actually looking for nitrogen. And if you look at this one has only 1 nitrogen. This one has about 2 nitrogen. Again, it appears that ammonium nitrate may have more nitrogen than this because it has 2 atoms. But we're not going to put it that way. We have to calculate it and see. We're not going to guess. We're not going to make a rumor. So percentage of nitrogen in ammonia, let's calculate it. It's going to be, the only nitrogen portion here is, I'm going to take this back too, so that's what I'm going to clean. Oh, if I clean it, that's going to go out. I'm going to leave the highlight. The nitrogen portion in this one, I'm going to use another thing, is only 14.01. Whereas the total nitrogen here is 2 times this, which is 28. This is, if you calculate this, 28.02 grams. This will be only 14 grams of nitrogen. So if we start doing our math well, this will be 14.01 grams of nitrogen divided by the total mass, 17.04 grams. Of course, grams will cancel grams, that's 100. And if you do this math correctly, this will give you about 82.2% of nitrogen. Now, in the second part, the B part, what are we going to do? In the second part, we're calculating the percentage of what? Nitrogen in ammonium nitrate. In ammonium nitrate. Of course, in doing that, here we know there is about 28.02 grams of nitrogen there. 28.02 grams of nitrogen divided by, what is the total mass of this guy? This guy weighs, this is gram per mole, of course. This guy weighs 80.06 grams. Then we multiply it by 100. And when you do that math, you're going to get about 35% of nitrogen. Now, when you compare these two, again, remember, ammonium nitrate has 2 atoms of nitrogen, just like we saw here. Whereas ammonium nitrate has 2 atoms of nitrogen. Ammonia alone has only 1. But at the end of the day, because the molar mass of ammonia is only 17.00, here you have about 8. That is why when you divide it, it actually contains more fraction of nitrogen than ammonium nitrate. So the answer is this guy. I say quantitatively means solve it. Quantitatively means solving. What is the number? The number is 82.2%. And the reason why it has more nitrogen is because the ammonium itself has a molar mass of 17.04. So if you compare 17.04 to 14.01, you find out that most of the mass of ammonia is just the nitrogen in it. So this, if you want to make decision as an agricultural businessman or tycoon to get a fertilizer that will give you more, that will nourish your plant with more nitrogen, what you want to get is the ammonia fertilizer. All right, having said that, we're going to pick it back to again, another very wonderful and applied question. Reflection 4. It says, what is the percentage biomass of carbon in caffeine? We are living in a caffeine nation, caffeine economy, where everybody drinks caffeine to get activated in the morning. So now what we're going to do is to calculate the amount of carbon, or the percentage of carbon, biomass of carbon in caffeine. And this is the formula for caffeine, C8, H10, N4O2, quite a big number. So report your answer in 2 decimal places. Let's do this. So the first step here, the first thing we're going to do is to calculate the molar mass of this guy. By starting, use a periodic table to look it up. There are 8 carbons here, and each carbon weighs 12.01, if you use a periodic table to check that up. Plus, there are 10 hydrogens. Each hydrogen weighs 1.01 from the periodic table. Plus, there's 4 nitrogen. Each one weighs 14.01. Plus, there is 2 oxygen, and each oxygen weighs 16.00 from the periodic table. If you add all this together, of course, if you multiply them, this one will give you about 96.08 grams of carbon. This one will give you about 10.1 grams of hydrogen. This is carbon of hydrogen. Multiply the nitrogen. Nitrogen will give you about 56.04 grams of nitrogen. And the oxygen there will give you about 32.00 grams of oxygen. We're not interested in other constituent elements. We're only interested in what? In calculating what is the contribution of what? Carbon, which is about 96.08%. So let's do it. Percentage carbon in this guy will be 96.08 grams of carbon divided by the total mass. Oh, I didn't do the total mass. Now, if you add all this stuff together, you're going to get 194.22 grams for 1 mole of caffeine. So 1 mole of caffeine will contain 194.22 grams. So if you put that total under here, 194.22 grams, then you multiply it by 100. And when you do your math correctly in your calculator, you're going to get actually 49.47% of carbon is contained in C8, which is caffeine, H10, N4, and O2. And this becomes our correct answer. All right. Having said that, we've come to the end of this lecture once again. Thank you for listening. Bye at this time.